Howdy, partners. That was really bad. Okay, we got a lot to cover in this one, so I'm going to go kind of fast at the first. Yeah, so we're talking about 2.7. This is the last section of Chapter 2. It's called Arithmetic Sequences. So, FIF3, recognize that sequences are functions, sometimes defined recursively, which we'll talk about what that means. Some vocab, sequence, term of a sequence, arithmetic sequence, common difference, recursive, and explicit formulas. Okay, so a sequence is just an ordered list of numbers that often form a pattern. Each number in the list is called a term. Okay, term of a sequence. Sequence is an ordered list of numbers. Okay, you can identify when a pattern in a sequence. When you identify a pattern in a sequence, you can use it to extend the sequence. You can also model some sequences with function rule, like an equation. Okay, so let's look at A down here. Describe the pattern of the sequence. So it goes from 5 to 8, then 11, then 14. So first you want to see if it's adding something. This one's adding 3, and then 3, and then 3. So that's the pattern. What are the next two terms? Well, if we continue to add 3, we get 17, and then 20. Okay, this one goes 2.5, then 5, then 10, then 20. So it adds 2.5, adds 5, adds 10, and so on. So it's not adding the same thing each time, but it is doubling. So this one's multiplied by 2, times 2, times 2. So if we do 20 times 2, we'd get 40. 40 times 2 would be 80. Those are the next two terms. Okay, so that's an example of a sequence. So look at these ones, see if you can figure out the pattern and then the next two terms in each of these. Okay, I'll let you work on that. So pause this in 3, 2, 1, pause. Okay, so the first one you were just adding 6 every time. So we get 29 and then 35 and then 41 if you want to go 3. Okay, the next one you were dividing by 2 every time. So you get 50, then 25, then 12.5. The next one you're multiplying by negative 2. So you get positive 32, then negative 64. And then the last one you're just adding 4 every time. So you get 1 and then 5. Okay, moving on. So there's some sequences. An arithmetic sequence. Now this is called arithmetic, not arithmetic. Let me give you a short language arts lesson here. Arithmetic, something like that, okay. Arithmetic is a noun. That's talking about just adding, subtracting numbers, multiplying and dividing numbers. When it's used as an adjective, like arithmetic sequence, it's used to describe something. We pronounce it arithmetic, not arithmetic sequence. So it's arithmetic sequence. So an arithmetic sequence, the difference between the consecutive terms is constant. So basically you're just adding or subtracting something every time. So not the multiplication ones. So if we look at this, what you're adding or subtracting is called the common difference. So this one is going up 5, and then up 5. So this one is arithmetic because the common difference is 5. So D for common difference, it is arithmetic. Yes. This one goes up 3, then up 4, then up 4. So this one is not arithmetic, and I'm not really sure what the pattern is here, but it's going up 3 and then 4. So it's not arithmetic. Okay, look at these ones, see if you can figure out if they're arithmetic or not arithmetic, and if so, find the common difference. Okay, so pause this in 3, 2, 1, pause. Okay, so the first one goes up 7, and then 8, so it is definitely not an arithmetic sequence. The second one goes up 2 every time, so it is, yes, an arithmetic sequence, and your difference is positive 2. C, it goes down 6 every time, so it is arithmetic, and the difference is negative 6. And D, actually just alternating between positive 2 and negative 2. So in other words, you're multiplying by negative 1 every time. So there is a pattern, but it's not arithmetic because you're not adding the same thing each time. Okay. Next. Okay. A sequence is a function whose domain is the natural numbers and whose outputs or whose range are the terms of the sequence. Okay. So n is going to be the term number. So n is the term number. A of n is the value of the term. Okay, so if we look at this one right here, this sequence, this is going to be our first term, this is the second term, this is the third term, and that's the fourth term. So this is going to be your domain here, and then the value is actually going to be the range. So 7, 11, 15, and 19, those are your range values. 1, 2, 3, and 4 are your domain values. So we can use a recursive formula that relates each term of the sequence after the first to the ones before it. So recursive formula always refers back to the previous term. So if you look at this, the value of the first term, a or a1, is 7. So a is just the value of the first term. That's just this guy right here, 7. a2 is 11. That's the value of the second term. a3 is 15. a4 is 19. So if you notice, you're adding 4 every time. Okay, so if we want to find the nth term, we go back to the previous term, so the n minus 1 term, and then just add 4. Okay, so this is the recursive formula. This part anyway, not this part. Okay, so you say your value, basically, you go back to the previous term, and then add 4 to it. Okay, so your recursive formula needs to have 2 parts. It needs to have what the first term is, and then the pattern, basically. So for an arithmetic sequence, it will always look like this. A1 equals whatever the value of the first term is. And then an, you would say, is an minus 1, so that means the value of the previous term, and then plus your common difference, which we'll call d. So in this case, we started at 7, so we'd say a1 equals 7, and then an, so your nth term. So if I want to find any term, I need to go to my previous term and add 4. Okay, so this would be the recursive definition of that sequence up here. Okay, recursive, some sequences are only defined recursively, but most of them, recursive is not that useful because, say I want to find the 100th term here, a100, I still need to find the 99th term, and before I can add 4 to it. And then to find the 99th term, you have to find the 98th term. So it's not super useful, so I'm going to show you another way, which is called the explicit formula, and that's going to come up in a couple slides. But let's practice on recursive formula first. Okay, so if we do it for this one, find your common difference. I'm adding 7, adding 7, adding 7. Okay, so the first thing I'm going to say is a1 equals our first term, which is 70. And then I say an equals our previous term, n minus 1, plus 7, because that's our common difference. So if I want to find the 8th term, well, to do it this way, I've got to keep adding 7, so I'd get 98, 105, 112, and then 119. That would be our 8th term right there. So that'd be 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 119 should be your 8th term. And this would be the recursive definition. So you're really just filling in 2 things. You're filling in the first term, and then what the common difference is right there. The rest of it all stays the same in basically all of these arithmetic problems. Okay, so try and find the recursive formula for each of these, and then find the 9th term. Okay, so go ahead and try that. Pause this in 3, 2, 1, pause. Okay, so I went ahead and found the 9th term in all of these. In this one it's 51, because it's adding 6 every time. This one is adding 12, so it's 119. This one's 11.3, because it's adding 0.5. And this one is 25, because it's subtracting 9 every time. So I've written down the recursive in formula just for a and d, because I wanted to save myself some time. So a, I say my first term is 3. So that's right here. That's that 3. And then an equals an minus 1 plus 6. That's from your common difference right there. For d, my first term is 97, so that's here. And then an equals an minus 1 minus 9. And that's because it's going down by 9. So you're adding negative 9 or just subtracting 9. Okay, so we can check this. If I want to find the 9th term, I have to go to the 9 minus 1th term, which is the 8th term, and then subtract 9. So if I go to the 8th term, that would be this guy right here. That would be 34 minus 9, which would be our 25 there. Okay, so it does work. You just have to know all the previous terms. So that's why recursive formula can be not very helpful sometimes. So what is helpful is the explicit formula for all of these. So this is basically just the equation you can write, or the function you can write for any arithmetic sequence. So we're going to start with an, which means our nth term. This is going to be the first term, so we're going to replace this with the first term. N is your variable, so that's what term you want to find out. And then we're going to replace d with the common difference. So we're only replacing these 2 things right here when you write your explicit formula. the first term, and the common difference. So the same thing as the recursive, you only have to know the first term and the common difference. And then n is your variable, so that stays as n. Okay, so if we look at this example down here. Okay, an online auction works as shown below. So bid 1 is 200, bid 2 is 210, 220, 230, etc. So notice we're adding 10 every time. What is the 12th bid? So first we can write an explicit formula, which again looks like this. an equals our first term, a1, plus n minus 1 times our common difference. So we just need to locate this and this. So an equals our first term, which is 200. So I'm not going to say a 200, no, because that would mean our 200th term. I'm just going to say 200 plus n minus 1 times, it's going up by 10. So that's going to be our common difference. Okay, so that's our formula. That's called the explicit formula. Okay, if we want to find the 12th bid, I just need to plug 12 in for n. So a of 12 equals 200 plus 12 minus 1 times 10. 12 minus 1 is 11, so 200 plus 11 times 10 is 110. So the 12th bid is going to be 310 big ones, smackaroos. Okay, so this one is nicer because you don't have to know the 11th term and the 10th term to figure out the 12th term. You can just plug 12 into the formula. Okay, if I wanted to find the 100th bid, I'd plug 100 in for n, which would be here and here. Okay, so I get a of 12 equals 310. So that means the 12th term is going to be 310. Okay, so I'm going to have you try this one. It's talking about a subway. It has a subway pass, starts at 100. After one ride, it goes down to 98.25. After two rides, it goes down to 96.50. And three rides, its value is 94.75. So you got to find the explicit formula. So find the common difference, and then find the value of the pass after 15 rides. Okay, so I'll let you try that, and then I'll do it as well. So go ahead and pause this in 3, 2, 1, pause. Okay, so I wrote out the sequence again, and I figured out it's going down by $1.75 each time. So each ride basically costs $1.75. So I set up the explicit formula here. So my first point, which is 100, that's here, plus n minus 1 times the common difference, d, which is negative 1.75. Don't forget your negative, or else that would mean it's going up. And then I just plugged in 15. So I said a of 15 equals 100 plus 15 minus 1. So I plugged it in for n times negative 1.75. That's 100 plus 14 times negative 1.75. And then that came out to be $75.50. So after 15 rides, you're still going to have $75.50 on your card. Okay, next, so we can convert from an explicit formula to a recursive formula. So an arithmetic sequence is represented by the recursive formula, an equals an minus 1 plus 12. If the first term is 19, write the explicit formula. So it's already given us the two things we need, which is the first term here and a common. Alright, so this paused somewhere, so I don't know where I left off, but this is basically giving us our first term here, which is a1, and then the common difference, which is here, of 12. So we have the two things we need to write the explicit formula. So we say an equals a1, which is our first term of 19, plus n minus 1 times our difference, which is 12. Okay, and we can just leave it like that. And this is our explicit formula. Okay. So again, you're just looking for two things, the first term and the common difference. Okay, so go ahead and try these. It's giving you the recursive here. Oops. And then you want to change that to explicit. So go ahead and pause this and try it in 3, 2, 1, pause. Okay, so the first one, your first term is 21, common difference is 2, so 21 plus n minus 1 times 2. B, our first term is 2, so that goes here. Our common difference is 7, so 2 plus n minus 1 times 7, and that would be the explicit formula. So recursive has two parts. It says an equals n minus 1 plus something, and then it also states the first term. The explicit only has one equation, which looks like that. Okay. Alright, now we want to go from explicit to recursive. So basically if we look at this, remember your explicit formula is this, an equals a1 plus n minus 1 times d. Okay, so if we match this up, A1 goes with 32 there, and D is 22. So in this case, to write the recursive formula, all we say is what our first term is, A1 equals 32. And then we say AN equals the previous term plus 22, because that's our common difference. Okay, so you're just filling in, again, these two things. First term and common difference. Okay, last one. I'm going to let you guys try these, and I will do them as well, just so you guys can check. So go ahead and pause this in 3, 2, 1, pause. Okay, so for A, our first term is going to be 76 there. So I write A1 equals 76. Our difference is going to be the 10. So AN equals AN minus 1 plus 10. So that's your recursive part. For B, first term is 1, and common difference is 3. So A1 equals 1 is our first term. AN equals AN minus 1 plus 3. And your common difference is over here at this 3 right there. So that is all I have for arithmetic sequences. So make sure you can write the recursive and explicit formulas for all of those, and you should be good. Okay, make sure you guys do the Canvas quiz, and I will catch you all on the next one. Okay, peace out. Make good choices. Bye.